Oh, hi Year 12. Didn't see you come in there. Well, seeing as you come in, may as well have a little lesson on integration and finding the area under a curve. So here you can see an example question. Find the area between the graph of f of x and the x-axis between x equals minus 1 and x equals 2. And we are given this diagram, and f of x is the curve 7 minus x squared. So you should have already found out from your investigation that when you want to find the area under a curve, then that has something to do with the definite integral. So we want the area between x equals minus 1 and x equals 2. So we want this area here. And that is what turns out to be what you get if you do the definite integral from x running from minus 1 to 2 of the function f of x, which is 7 minus x squared dx. So in order to find out this area, we're going to have to work out this definite integral here. So let's come up here to do our working out. So we want the integral from minus 1 to 2 of 7 minus x squared dx. So we know that the area will be what we get if we integrate. So we integrate the function, we'll get 7x minus x squared will integrate to x cubed over 3, and that needs to go between 2 and minus 1 down here. And now we substitute in the limits. So we have 7 times 2 is 14, minus 2 cubed is 8, so 8 over 3. That's the top limit done. Now minus the bottom limit, so 7 times minus 1 is minus 7. Minus 1 cubed is minus 1. So minus 1 cubed over 3 is minus a third. But we have an extra minus sign here, so this is going to be plus 1/3. And if you tidy up that working, you should find that the area is exactly 18, and its area, so it will be, let's call it units squared. So let's have a look at a second example. Find the area between the graph of y equals x squared minus 9 and the x-axis. Now here, we don't have a picture, but you should know that the graph of y equals x squared minus 9 will look like the graph of y equals x squared, but it will have been translated 9 units down in the y direction. So it looks something like this. Y equals x squared minus 9. And we want the area between that graph and the x-axis, so we want this area here. But you'll notice we don't know what these limits of the integrable area are, so we're going to have to work them out. But the limits are simply the x-intercepts of the equation y equals x squared minus 9, or the roots of the equation y equals x squared minus 9. So the roots will be where y equals 0, so we're going to have to solve x squared minus 9 equals 0. So to solve this, you should recognize that this will factorize as the difference of two squares into x plus 3, x minus 3 equals 0, which is going to give us two x answers of x equals minus 3 and x equals plus 3. So this must be minus 3, this must be at plus 3. So the area that we want is going to be the answer to the definite integral of x squared minus 9 dx running from x equals minus 3 up to 3. So we're going to need to work that out. So if we integrate the function, x squared will integrate to x cubed over 3, minus 9 will integrate to minus 9x, and write the limits in again. Now we substitute in the top limit, and we will get 3 cubed, which is 27 over 3, minus 9 times 3, which is 27 again, minus what you get when you substitute the bottom limit. So minus 3 cubed over 3, minus 27 over 3. minus 9 times minus 3, which will give us plus 27. And if you work this out, then this bracket, 27 over 3 is 9, so 9 minus 27 is minus 18, minus this bracket, which is minus 9 plus 27, which is just 18. So our final answer is minus 36 units squared. Now that might seem strange to have a minus sign with an area, but that is simply because we are integrating a function and we're looking for an area that is below the x-axis. So on the last question our area was above the x-axis and we got a positive answer. Here the area is below the x-axis, so our answer is negative, and that will always be true. But we could say the area, or the positive area, is just 36 units squared. So in this final example we're asked to find the total area between y equals x cubed minus 4x and the x-axis, and that is all the information we've got. Now if you go ahead and graph this function on your calculator, you'll see it looks something like this, like that. Okay, so this is the graph y equals x cubed minus 4x, and we're asked to find the total area between this graph and the x-axis, so we want this section here and this section here. And before we can do any definite integration, we need to know what the limits of that integral will be. So we actually need to figure out what are the x-intercepts here and here, and actually we're going to figure out this one as well, because without them we can't figure out where the limits of our integration will be. So to do that we need to ask, when does this equation x cubed minus 4x, when does that equal 0? That will give us the x-intercepts, or the roots of the equation. So looking at this, we can factorize an x straight away, and we get x squared minus 4 in the brackets, and this quadratic expression here we'll factorize again, so that we actually get x bracket x plus 2 bracket x minus 2 equals 0. So we have three solutions. X equals 0, because if x equals 0 this will cancel everything out and it will equal 0. Or we have an answer when this bracket equals 0, which is when x equals minus 2, or when the third bracket equals 0, which is when x equals 2. So we have three roots on our equation: minus 2, 0 and 2. So it looks like to find the area we could simply work out the definite integral from minus 2 to 2 of x cubed minus 4x dx. And if you go ahead and type that into your graphical calculator using the math and then function integrate command, then you will actually find that this comes out to equal 0. But clearly, looking at our graph, the area is not 0. And you can probably guess what's happened. This area below the x-axis, which is a negative area, has actually cancelled out the area above the x-axis, which is a positive area. So we can't do this straight integration if we want to find the total area between the graph and the x-axis. We're going to have to split it up into two sections. One section from minus 2 to 0, and another section from 0 to 2. So we're going to do that now. So we'll split this integral into two pieces. The first integral will go from minus 2 to 0 of the function x cubed minus 4x dx, plus the integral from 0 up to 2 of the same function x cubed minus 4x dx. I know before I even do it, just looking at the graph, this area is going to be negative. I will deal with that when I get to it. So integrating the function x cubed minus 4x gives us x to the 4 over 4 minus 4x squared over 2 from minus 2 to 0, plus, it's the same function so it's the same integral, x to the 4 over 4 minus 4x squared over 2 from 0 up to 2 this time. So just move this up here. Let's look at this bracket first in red. So sticking in 0, or substituting in 0, simply gives us 0, minus, substituting in minus 2 to the 4 over 4, that gives us 16 over 4, minus 4x squared over 2 will give us 16 over 2, which gives me, when I simplify it, 16 over 4 minus 16 over 2 is minus 4. With this minus sign outside the front, gives me an answer of 4, which is the area under this part of the curve here. We can do this section in blue. Substituting in 2 will give us 16 over 4, minus 4x squared over 2 will give me 16 over 2, minus, substituting in 0 will just give me 0. So this whole thing here, 16 over 4 minus 16 over 2 is minus 4. So you can see if you simply add these two numbers together, the negative area cancels out the positive area and it looks like there's no area at all. But seeing as we're just looking for the total area, I'm going to ignore this minus sign. The minus sign is only telling me the area is underneath the x-axis. That's all it means in this case. So the total area is simply 4 plus 4, which is 8 units squared. So I hope those 3 examples have helped you understand a little bit about the sorts of requirements asked of you when finding the area under curves using definite integrals. We'll get a bit more practice on Thursday. Come along with any questions you've got about this video, because this one was quite involved and it's at a higher level than we've been working at recently. So think of any good questions you want answering, and I will see you then.